Hi everyone, we're going to present our final project about database for medical clinic. Hi, my name is Jenny Foong. First, I will explain our ERD and business rule for this database project. This is our ERD entity relationship diagram. From this ERD, we can know that a patient may make many appointments with one or more doctors in the clinic. A doctor may accept appointments with many patients. Each appointment is made with only one doctor and one patient. Each patient visit is recorded by one doctor and each doctor may record many visits. A patient may attend many visits and a visit is only attended by one and only patient. Each visit produces at least one visit detail, but each visit detail is made from one and only visit. Each visit may produce a bill, and each bill may produce by a visit. Each billing may or may not adjust many insurance payments, while one insurance payment can be adjusted by one and only bill. A patient may include many payments, but each payment is only made by one patient. A payment must reduce the amount of one bill, and a bill may reduce many payments. An insurer may or may not pay insurance payment, but each insurance payment must be paid by one and only insurer. An insurer may insure many patients, and the patient is insured by the one and only insurer.
Hi, my name is EDVIN, and right now I'll be presenting our data definition language for our database project, and this DDL is for medical clinic database. So according to business needs and the business rules and ERD diagram we have created, we have to make 9 tables. The 9 tables are insurance, patient, doctor, appointment, visit details, billing, payment, and insurance payment. The constraints of our DDL will be mostly not null, which is column level constraint, primary key, and foreign key, which are table level constraints. The first table we have to create is insurance. Here we have insurance code, and we set this to varchar 2 with a size of 6. The reason why we choose varchar 2 for most of our columns is that it can store characters, alphabets, and letters, so it's easier to store it in varchar 2. For most of our columns, we will be using not null, which requires the user to input the data without leaving it blank. So here we have insurance code, insurance name, insurance phone number, and insurance email. Insurance phone number we have to use 14 because sometimes the phone number can have dash. And for email, we choose the size of 50 because email tend to be very lengthy. So for this table, the primary key of this insurance table is insurance code. Our second table is patient. Here, patient number will be our primary key, and we use it as number. We only put 3 because we only count the number of patients. For patient last name and patient F name, we use varchar 2 with a size of 50. The reason is that the names can be quite lengthy, and also the date of birth here we use the data type date. Dates allows us to store the dates of our data. As a phone number, same reason, use varchar 2 with a length of 14. Email, since email can be lengthy, we have to put it to varchar 2 with a size of 50. But this is the only attribute we don't put not null. The reason is that we know that some patients, they do not have email, so they are unable to answer this field. That's why we have to remove the not null. And then finally, insurance code will be our foreign key, which is from this table, insurance. Our third table is doctor. Doctor ID will be the primary key for this table, as it is set here. Then we have doctor last name, doctor front name, which is set to varchar 2 with a size of 50, and also doctor's office number for easier reference. Our fourth table is name appointment. In this table, appointment number will be our primary key, and we set this data type to number with a size of 3. Appointment date, we have to use data type date. Appointment schedule, we have to use varchar 2 15. The input for this column will be based on the situation of the patient. For example, if the patient is under emergency, it will be written as unscheduled. If it's not emergency cases, then it is written as scheduled. Doctor ID will be the foreign key from the doctor table, and patient number will be the foreign key referencing the table patient. For our next table, we'll name it visit. In this table, visit number will be set as a primary key, and its data type is number with a size of 3. This table also takes doctor ID from the table doctor and patient number from the table patient as the foreign key. Here is our visit date, and we set it data type to date. As for this table named visit details, it will be based on this table. Our primary key will be taken from the table visit, which is visit number, references, visit. Here we have our details of patient, so we have details diagnosis and details treatment. We set this varchar 2 size to 50 because the diagnosis and treatment will be lengthy. Our next table is called billing. Here we'll take billing code as our primary key, and we set it to size of 6, varchar 2. Here we have bill pay amount, and we use the data type number. We use 6 digits and 2 decimal places to store the money. Here we have to put not now. The date, we have to put day as well. The balance, same reason as the pay amount. Since we are dealing with money, we have to use at least 6 digits with 2 decimal points. The visit number is taken from the table visit as a foreign key, and the same goes to doc ID and the patient number, as shown here. Our next table is named as payment. Here we will take bill code as our primary key, which is also a foreign key from the table billing. We have a payment date, and we set it to data type date. Payment amount set to data type number with the maximum of 6 digits with 2 decimal points. Payment type, we set it to varchar 2 50, and patient number is taken from the table patient. Our last table, which is named insurance payment, will make insurance payment number as our primary key. We set it to number with a size of 4. Insurance code will be referenced from the table insurance. Bill code references the table billing. Insurance amount, we set it to number with 6 as the maximum number of digits with 2 decimal points. And then we have the insurance payment type. We set it to varchar 2 to the size of 50. Because payment type can be quite long depending on the situation of the patient. So that's it for DDL. Now I'll be running the entire script to see whether this script works. As you can see, all the tables are created successfully and there's no errors.
Hi, I am KANG. At this part, I'm going to present data definition language. First, we have the table patient, which record the basic information of the patient. And next, we have table appointment, which act like a schedule of appointment between the doctor and the patient. Here we also have table doctor, which record the basic information of doctor, and table insurer, which record the basic information of company insurance. And we have table visit, which will record the visit number, doctor ID, patient number, and the visit date of a patient. And table visit details, which record the diagnosis of a patient and treatment by doctor. Now we come to table billing, which store the cost of the bill, the pay amount, the pay date, the balance, the visit number of a patient, the doctor ID, and the number of patients. And table payment, which basically record the information of a payment. It has include the cost of the bill, the date of a payment, the amount of the payment, the type of payment made by a patient, and also lastly, the patient number. And now come to the last table, insurance payment. It stores insurance pay number, insurance code, bill code, insurance amount, and also insurance pay type. Now we are going to run our SQL script. For avoiding any technical problem, we are going to drop the table with the same name. Then we run. As you can see, based on the result, the table which has the same name has been dropped and create a new table. And all table is created successfully. In this part, I'm going to present data manipulation language, insert, update, and delete statement. First, insert. For example, insert a new data to table appointment. Before, the table appointment has only 2 data. After we apply our SQL, it becomes 3 data. Next, update. For example, update the office number to 003 where ID of doctor is D00101. Before, we can see that the doctor ID, which is D00101, has the office number, which is 1. After we apply our SQL, it updates to 3. And last, we are going to talk about the delete statement. For example, delete the data about doctor ID, which is D00101 in table appointment. Before, we can see from the table, it has 3 data, included the doctor ID, which is D00101. After we apply our SQL, the table will delete the row of data which is about the doctor ID D00101.
Firstly, data query that involve the selection and protection operations we can use to retrieve the row and project. If we have a problem, retrieve the doctor ID and the doctor names where the office number is not 001. So here's the RA. And we can use the select doctor ID, doctor first name, doctor last name for the doctor where the doctor number is not 001. So I'm gonna demonstrate this SQL statement in the Oracle aspect. Here is a SQL workshop. These are SQL, doctor ID, doctor first name, and as names for the doctor where the doctor office is not 001. So I'm gonna run, execute the statement. it will show the table. The D00112 is a total ID, and the Gabbard Cornell. This is a total ID, and the total names is not, the total fixed number is not 001. Next, I'm gonna show you the data query that involves the aggregation and grouping operation. If we have a problem like retrieve the total number appointment ID, appointment schedules, and total ID is D001, we can use the aggregation and grouping operations as shown and below. So as you can see, how actually is aggregation used to count the number of row or appointment number, and group by appointment schedules. For the appointment table where the condition is total ID is equal to D00112. So the appointment schedule actually is divided by 2, which is schedules or unscheduled. If the patient doesn't have appointment, they are emergency, we put the unscheduled. So the select count will retrieve the data based on the appointment schedule. When they will count for schedules and unscheduled, how many number of schedules and how many number of patient is unscheduled, which is emergency. So this aggregation and the grouping for the problem just now. So I'm gonna execute this SQL statement. It will show the table below. As you can see, they will count the appointment number based on the appointment schedules. So the unscheduled is 1 and scheduled number is 1, where the condition is D00112 for the total ID. So now we proceed to the next, which is data query that involves the join operation. Basically, we have two types of join operation, which is inner join and outer join. So here I'm going to present the inner join. If you have a problem like retrieve the names of the patient, full number of the name, appointment date, insurance name, with the order of date of birth of the patients, so we can use the join operation, join the 3 tables such as patient, appointment, and insurance by using the join command. So as you can see, the rational algebra, we project the 3 attributes from 3 different tables. As you can see, the patient first name and patient last name is from the table patients, and patient full too. The appointment date actually is from appointment table, and insurance name is from the insurance table. So if you want to project these 3 attributes from 3 different tables, you need to use the join operation. So if you're using the join operations, you need to know the same attribute of the table and try to relate. For the example, the patients and the appointment, they have the same attribute, which is the patient number. So we join the patient and the appointment table, but we also need to join the insurance too. So here we try to find out which table is related to the insurance table, which is the patient. They have a set attribute with the insurance table, which is the insurance code. So here that's a SQL code as shown as below. We select the patient first name and patient last name and patient phone number for the patients, and appointment date for the appointment table, and the insurance names from the insurance table. Then we join the three tables and based on their same attribute. So now I'm going to demonstrate the coding. So here, that's a coding for the question just now for the inner join. So we see what result we get. So we got the 3 patient names and 3 patient phone number and appointment date and the insurance names, and this SQL code will try to sorting your result based on the patient date of birth. So there's a command order by patient date of birth. So they try to sort your result based on the patient date of birth. For the previous one is the inner join. Now we're going to have the outer join. So the outer join basically has 3 types, which is left join and right join and full join. So as you can see, the question lists all the payment detail and all the patient table detail by full join. So why we need to use the outer join? This is because both of the table have different of row, so we need to use the outer join. So here's a SQL coding. So now I'm going to demonstrate at the SQL. Here's a coding for the outer join for the question just now. Now I'm going to execute. Let us see what the result we get. So as you can see, the table for the Muhammad Ali and Ayman Hazrat, for the bill code and payment date and the payment amount and payment type and patient's number, they are null. So that's a full join. So let us see what's the left join and the right join. So here we go. I type left join, see what result we get. So here the result we get we also same. So now we try the right join. So for the right join, the Muhammad Ali and Hazrat just now, the both of row doesn't show. Now I'm going to expand the data that involves the nested query operation. So here's a question: find the names of the patient who during this and have the visitor number 0201. So here's a SQL code. Now we're going to demonstrate in the coding. So this is the SQL code for the nested query for the question just now. List all the names of patients who are in the billing list and have the visitor number based on 0201. So now we run the code, see what result we get. So here's the result we get. So this is a statement that they execute first, which is the visitor number 0201. After that, next statement for this will be execute, then for the outer join. That's how the nested query works.